So today we are going to cover on the using Docker to deploy our application. Like we would be having our application. We install the application inside the Docker image and then we run that image. So why do we use that? This is all because of you have your changes properly being promoted to multiple environments, the same change. So let me probably explain it first and then we'll go into the system. Okay. So now we have seen this thing, right? So you have a Jenkins, right? And you have an agent. So that has a Docker installed. And then we created an image. So that image has a required softwares. It has a Maven, Java, and the Git packages, right? So we use this image to build our Jenkins job. So irrespective of the agent type and agent configurations, so we are completely isolated from the agent configuration and we created our own image to build our Java, build our build, right? Source code. This is done. So now we can also use this Docker image for other purpose as well. Okay. What is that other purpose? The other purpose will be this. So that is the main purpose. We usually use the Docker. So that is this. So you perform a build. Okay, this is Jenkins, this is agent. Let's assume so we are doing our build in the agent itself. So when you perform the build, right, so you get the package. So we have been talking about building, right? So we are getting the output. It can be a jar file, it can be a war file. So what is the use of that? So that jar file or the war file may contain, will contain your output of your code. So maybe you're developing a website, maybe you're developing some API endpoints. So those you need to deploy it if you want to see those changes. So where you will deploy? So you may deploy this into Tomcat, right? You may deploy into Tomcat, or maybe your application itself will come up, Spring Boot application, right? So this will serve your application. So the moment you run the jar file, Java, your jar file, and the whatever jar you have developed, it will bring your application up and running. That is another step. So when you deploy it into a VM, right? So if you deploy this into a VM, again you need to configure Tomcat, configure corresponding users, privileges, log file, and then copy the jar file. So once you start the Tomcat engine, your Tomcat engine will read the jar file and then it will bring your application up. That is what the deployment process happens, right? So same process, rather than we deploying this Tomcat into a VM, so we can deploy this into a image itself. So why we use this? What is the purpose of that is? So now you have a Tomcat jar file, right? So when you talk about development, agile development, developers continuously make changes to the source code, right? It's a never-ending process. They don't stop it. So every day they make changes, they push changes, they test changes. So you may lose track of which jar file is actually having all the changes that needs to go to the production. So let's suppose there is a Java artifact, we call artifact version, so which you are using 2.1.63. This is the jar file you tested in dev. Okay, so some user accidentally used the same version and added some more changes. Okay, so then same changes are also part of this package now. Some more changes. Okay, but this guy now verified in the developer provided the go ahead. Now what happens when you want to promote this to UAT? We don't generally build it again. So whatever jar file is created, the same file will be promoted to UAT environment and so prod environment. So UAT environment, this guy got promoted. same version name, but this guy different package. This guy got promoted. Now what happens? There is a discrepancy between dev and the UAT. Developer thinks that, so I have all the changes in this version and the same version is promoted, but the package is different. It's not matching with the SHA number. This guy promoted, they found no issues. This guy promoted, they found no issues, but they found issue that the feature that they are looking for is not visible here. Now whose fault here, right? So mistakes happens like this. So again, if you have multiple VM environments, you have to deploy the same jar into all the VMs. It's again a bit of a pain. To avoid all this, so we make use of Docker. It's called the microservices. I mean, we use Docker. Sorry, where is annotated? So what we do is, so whenever your build is completed, right? You create, you run the jar file. So jar file got created. Okay. So whenever you create this jar file, you write a Docker file from base image, and then you copy that jar file into this location. So you perform a Docker build. So when you do Docker build, so what happens? This will create the image. So when it creates the image, what happens? So whenever we create the image, we provide registry name followed by repo name followed by tag. So this tag we always use the build number or a specific time or maybe the commit ID of that build. So now build number is 21, 22, 23 will be like this, right? So this tag will be upgraded. So now you can say, so 23rd went fine successfully. So you will have your image like this, repo name colon 23. So now this image we need to promote it. So you don't need to configure anything. You don't need to configure Tomcat. You don't need to configure anything because you would be configure everything once with the Docker file. So now the moment you perform Docker run, your application will come up automatically. The same example, if it's take, we have Nginx, right? So what we did? So did we configure Nginx? Did we install the Nginx in an image? Did we configure the log files? No, everything is pre-configured. We just copied our index.html. So then the moment we run Docker run, our application came up automatically. So since we don't have the knowledge on the Java side, we used a basic index.html. But now, if you talk about the big applications like that using Spring Boot or AngularJS and all, now they have the jar file, they have var file. They'll give you the proper jar file that we need to copy. So once you copy that, you run that, boom, your application is up and running. Okay. Now let's see the same process how we do this with the Jenkins and with the normal. Okay. Probably I'll explain you first the offline, and then I'll explain you the same thing using with the Jenkins. Okay. So that you can easily understand. Annotate, clear all diagrams. Let me connect to my machine. Oh, okay, I'm in the box. Let me also, okay, Jenkins already up and running. Now I already have an example that we could use in our thing. If I go here, I have Yeah, Tomcat Maven app. So this is the source code. So source main web app. So what we are doing here, so we have one web inif, web XML something. This is about our typical source code. It doesn't have the testing, that is fine. And then we have a pom.xml. So this pom.xml will be building our application, which is good. And then, yeah, so first build this project and then we will see. Okay, so now I'm going to build this project. So we already have a Jenkins file here. Okay, it's good. That will make my work less. Now I'm going to build this project. So I will probably create a new item. I'll go into the Maven. This is Docker test, right? So I will create like let's say microservice. That is not typical microservice example, but let's consider it. Pipeline agent. So I'm going to use a Docker node. Image will be the one that we have created yesterday. It is Maven Alpine hyphen test, I think, yes. And the label that we have given is Docker node. This is done. Now I need to perform the builds stages, stage, checkout, steps. I need to perform the git command here. I'll come back. Next, I'm doing the build steps, sh, mvn, clean package. Yeah, that's it. So now let me take the example. Git. This is my thing. This is public repository, so I don't need to provide any credentials. Yeah, that's it. So I just have this thing. Now apply. Let's save. I'm going to build now. Yeah, it is building. We get some water. Yeah, it's success. Good job. So the build is succeeded. So if we look at the package, so the package is available at this location. So now let me log in to the box. Already I'm there. This is dependency. Let me go here. See, there is, yeah, this is the output. Java, Tomcat, Maven, example var. This is the var file contains my application. So I built the source code. When I build the source code, I did the package with the Maven clean package. So package means it creates the output file, output artifacts. This is the output artifacts got created, and this has this name. So now what next? So we need to deploy this into a Tomcat engine. Okay, to do that, what I'm going to do, I'm going to write a simple Docker file. So maybe first I'll copy this, copy this guy, go back to home directory. So we have Maven, right? So yeah, probably I'll copy it here. Okay, yeah, I copied. I go back to the Maven directory. I have the file here. So I'm going to write, but all the Docker file is here. I don't rewrite. So Docker file is here. Yeah, this is a Docker file. There is one more Docker file. Let me see. What is this? This is Maven. Yeah, no. This is Docker file. Let me copy the content. So new file. So what I'm using from Tomcat. So Tomcat is an base image. I'm removing this directory here. I'm copying the file here. So my var file is here directly. Copy this var file, put it here, and then I'm going into there. I'm unzipping in the var. I'm removing the var file again. So what I'm doing is I'm just unzipping this into this directory. That's it. And I'm exposing this on port 8080. Okay, and I'm running a command catalina.sh. This is called your Tomcat related. Okay, if you want to bring up your Tomcat's engine up and running, so you need to run this. The moment you run this, it will automatically bring your applications up, whatever we have installed. This is a typical Docker image. Now I'm copying this, creating a Docker file with a Tomcat, paste it here, and then save. Now build this. Docker build minus T. I'm going to give our thing Maven colon Tomcat test. So minus F Docker file Tomcat build here. So Docker build tag is this, file is this from this directory. Now let's see. So it is pulling, it is pulling the images. Done. So my Tomcat images application is run. Now, how do we run this? So we know the command docker run minus D in the background mode, minus P, we need to expose. I use 8080 with the 8080, and you can give the name as well. You can give the name as Tomcat. This is the image. Okay, so let's see. Oh, it's dash dash name. Yeah. So now if I see Docker PS, there is one running exposed on port 8080. Now let me go ahead and access my Docker. So I go back here, instances. See, this is what our application, this is what we build it. We don't know about all this. So this source code, whatever we have shown you here. So Tomcat Maven app, the source code contains this website details. So they have written the Java code to bring up this website. Okay, so what we did, we built it with the Jenkins file. We built it. So we have got our war file ready. So once our war file is ready, so what we did, we deployed it. Where we deployed? In a Tomcat. So in technically, you can also install a Tomcat engine in the VM, configure your Tomcat, and then at this location, you can deploy your war file and then run your catalina.sh. It will bring your Tomcat up and running, and then you can access your website. Or you can use the Docker image that has already Tomcat configured. You just put your war file wherever you wanted to use it and then deploy it. So now it's clear and running. This is a normal way. So now let's automate this using the Jenkins. So whatever this we are doing, we wanted to automate this everything. Okay, so we already have a Docker file written here. So what it is doing here is from same. So we would be having our var file here only, which is perfect. I'm just going to write the Jenkins file for to create the Docker image during the Jenkins creation time. Okay, so let me write the pipeline first for that. Jenkins file pipeline we know. So I'm going to run this on an agent Docker agent same. So it will be image. We have seen this already. Alpine test. Okay. No, I don't want to use this here. We need to perform the build. Yeah. Yeah, pipeline. Let's do directly. I will start with the stages. I'm doing the checkout and build part here. Steps. I need to use the same Git here. It is the configure. This is done. Now I am also performing directly here. MPN clean package. So here I am going to add the agent section. So rather than I'm adding here, I'm adding agent in the stage block. So what the significance of this is, so this particular steps will be executed on this agent only. So this agent scope is only applicable to this stage. So now I'm going to write one more stage here. This is creation of build. Okay, create image. So I need to create image. I'm opening this. Again, I use the agent section. I am running directly onto the Docker node. Okay, I'm not changing anything. Docker node. Now steps. So steps, we need to execute the Docker build. So what is the command? So Docker build is a direct command. So we could use that. Or we can also use the script and use the Docker pipelines. Since we don't have a Docker pipeline plugin installed, I'll use the shell command directly here. So I'm opening a shell block here. Okay, I'm using 3 shell blocks. So first, what is the first command? We need to build the Docker build, right? You need to give the tag, use the same tag. This is Tomcat, right? Tomcat test and minus. We have only one file, so we don't need to provide one file. Build here. So once my Docker build is done, what we need to do? We need to perform Docker push. So before that, we need to do Docker login, right? We need to do Docker login and then Docker push this thing. This is our create image and push it to registry. This is what we need to do. So here we need to pass the credentials. For the credentials, I am going to take an environment block here. Okay, I would say Docker login is equal to credentials. I'm just using this Docker login credentials Docker login. I'm going to create the credential over there. I'm going to use the same credentials here. So this is the user ID I'm using. I would say USR and minus P is the password. PSW, PSW or PSD, PSW. Yeah, we will see that. So now I got these variables ready. Now I need to create the credentials. I'll probably create on the Maven directly. Add credentials, username, password. So your Docker username and the password, right? ID. So which ID you have used here? You use Docker login ID. So I'm going to use the same ID here. Use the same description. Done. So we have a Docker logins created. It is PSW or PW? PSD. 1 minute. Let me just. I'm just checking whether it is a PSW. Yeah, it's PSW. PSW. So now what happens? So we have taken credentials, username, password, right? So these credentials will be loaded into this variable. Okay. So username and the password. So username will have Docker login underscore USR. Password will have underscore PSW. This is how the username password are stored in this variable. Okay. So now perfect. So this will build my package. Now I am running the same on the Docker node. So I'm using Docker build minus T this, Docker login this, Docker push this. So since we have single node, then it will work. So if you are working on the multiple nodes, like the Docker build may happen in machine A and this image will happen machine B. So in that case, we have two different machines. So your var file is created here in this agent, which is machine A, and machine B may not have that. Then how do you solve that? We need to do the stash and unstash. Stash means, so whatever var file we needed in this step, we need to copy from here and then paste it here. To do that, we call stash and unstash. I think we have seen this in our previous Jenkins example. Okay. that you can see that stash and unstash. So now we have done. Now let's go ahead and let me use this. So stage, yes, stages are there. Docker login environment is there. Okay, let's go ahead and create this our Jenkins job. I'll use the same microservice here. Configure. Now let me build now. It's failed. Oh, okay, I got it. So since we are not using the agent here, so we need to mention agent none. Because we are not using the main single agent, right? So we need to mention agent none here because we are using agent inside the stages. So clean is package is happening. Let it happen. Build succeeded. Now I'm going to the second step. See that Docker build successful, Docker login succeeded, and Docker push is also succeeded. See Docker login minus u minus p, Docker login, Docker push also succeeded. So our image is available in the Docker Hub. Let's go ahead and check it. So it's inside the Maven and the image name is Tomcat test. See, a few seconds ago. So now we have our image ready. Now we can deploy this into any other machines. Now, if you really wanted to use your Docker machine, so if you have Docker running, so you can use this image to run it. The moment you day minus Docker run minus p with the port, your image will be up and running. So this is the jar file. So similarly, in microservice concept, what we do, so we would be having the UI part in one repo and your jar in Java source code in one repo, your back in one repo, and you would have some other modules in another repo. So what they do, they have their own Jenkins jobs. They have their own build process. So the moment build completes, they create an image like this and push it to the registry. So now we just have only one image. So we pushed it to registry. So when we want to deploy that, so deployment means we need to run that. We need to run is a deployment. So deployment also, let's write the steps. So here, let's assume we are deploying again onto a different node. So this is the stage, right? I'll add one more stage, deploy. Okay, let's assume we are now deploying in another node. Okay, not on the same node. Steps. So what is the command to deploy? We need to execute the Docker command. The command is Docker run minus p. Port we need to expose, right? 8080. You can give the name if you want, Tomcat. And then I generally don't prefer giving name because if the process already exists with the same name, then it will fail. So I remove the name part and then I give the image name, Docker Maven Tomcat test. So and yeah, that's it. So we need to use a minus d parameter because we need to run in the background. Docker run minus d minus p this. Okay, that's it. So now let me say one thing. So whenever I build, the same tag gets created, right? But I wanted to have a different tag. Whenever I make some changes, I wanted to have a different tag for that. So rather than using Tomcat test here, let me change the build number here to the build number. Okay, there is a environment variables. in the build. So Jenkins environment variables, not build URL, build number. So this will be build underscore number. Yeah, so there are environment variables that you could use. So I have a build number here. I'm going to use it as a tag. Okay, so this is the build number. So rather than here Tomcat tag, I'm going to give dollar build number. Same thing. Sorry, I'll use Tomcat hyphen build number. Dollar build number, and then here also dollar build number. So now what happens? So wherever it says dollar build number, so this will be replaced with the build number that we are running. So let's suppose this build number is 3, right? 3 will be replaced here. So I have a Tomcat 3, Tomcat 3, and Tomcat 3. Okay, this is what the deployment. Let's assume. So this is a different node, this is different node, and this is different node. Okay, we're assuming that 3 different environment. Let's suppose this is a development environment. This has a dev Docker VM running. Okay, so now what am I going to do? I'm going to run this as it is. So let me just check if it is Docker already running here. Docker PS, we have this. So let me Docker kill, or you can do Docker stop as well. So Docker PS, it is no more running. Now I am going to run this as it is. So
Lokesh,
mhm,
you said you have to write down like a Docker stop. If you stop that one, the whole container will stop.
yes,
So if you kill the particular ID means we have to
it will be killed
kill
completely.
that particular ID only, right? If you kill the ID one.
No, I mean the even though you stop or kill, you execute towards the container. So when you run the image, the container will be run and you will see the container with an ID. It doesn't have any name of it
Yeah,
unless you
that's
provide something. So you stop and kill both says. Let me show you. So here are some, I think I have added here for the, where is DevOps? Docker. Yeah, I added here Docker stop and Docker what they do. That just stops the running container. If you say kill, it kills it completely.
running container. That kills
Hmm.
the running.
Yeah.
Thank you.
So now, where are we? We need to deploy this, right? So yeah, so we have this. I am also adding this step, Docker RMI, because it's a good practice. So once you push your Docker image, you don't need to keep them in a machine. Unnecessarily, it creates a burden, right? I am also deleting that from the local machine so that it will be cleaned up. So I'm copying this. Now I'm going here, configure. So rather than we copying it here, so let's do one thing. We will, no, let's let it be. Yeah, now build now. Build is happening. So this image is pushed, you see. So Docker got deleted here. See Docker RMI, so it deleted. So we have saved some space. You see the tag name now, Tomcat -4. -4 is because of the build number. Let's go ahead and check it in the one this here. So now we see our tags as a Tomcat 4. Okay. So now development team. So if I go ahead and deploy it, I think it's already deployed, right? Did we added the deploy step as well here? There is a deploy step. It didn't run. Oh, sorry, it's in 4, right? So even deploy step also went fine. See, Docker ran this, so it did not find the image locally. So it pulled it from the Docker Hub and then it ran it. So now let's go ahead and see your application. Boom. See, it's up and running. So now developer thought to make some changes. So now he goes ahead and makes some changes to the source code. So let's go to the source code here. What they are doing, they have index.jsp here. Okay, so this is the thing. Now they wanted to make some changes to the source code. So now rather than here, they added this. They made the change, committed the change. Now the job will be run. You run the job. I need to stop this, otherwise it will fail, right? Let me kill Docker PS. Yeah, it's already failed. It's all because of that image already running, right? And port number 8080, it was failing, already allocated. So now we can do some stuff. So what we can do, Docker PS is here, we don't have. Let's run ourselves that command. What is that command? This is the command. Sorry. I'm going to add some more steps now. Docker run maven tomcat 5, right? So it's up and running, right? So I know this. So what I'm going to do, I'm going to look for this command, grep -i complete verification. So maven colon tomcat. If the process is up and running, so it shows I see wc -l. It says one count. It means it is up and running. So before that, I wanted to stop this. Okay. So how can I stop this? Docker. I need to get this container ID. So how am I going to get? Docker, same command as in wc. I need to get the awk uh, print $1. Yeah. So I got the ID. So I'm going to implement the same logic here. So rather than the shell block, I take one shell block, kill this guy. So first I need to verify if the process is running or not. Docker ps grep -i. What I need to do? Maven tomcat and check the wc -l. Okay, if I'm going to store this in a variable, right? Process check is equal to dollar this guy. If I know this dollar process check is equal to 1, then what you need to do? You need to kill it. Docker kill. I need to get the output here. This command. That's it. So what I'm doing, I'm just doing this. They'll give me 1 if it is up and running. So if it is equals to 1, it is up and running. So I'm first killing it. So I'm just killing the existing process and then I'm starting it. Okay, that's it. Fee. So perfect. Now let's go ahead and run this. Did I do any mistakes here? Nope, I think. Yeah, this is perfect. Now let's go ahead and run this application. See, we just started with small change, but while adding more features, it becomes 50 lines, right? This is how the file, the source code also gets bigger. So it is running. So let's see if the Docker process actually running here. Yes, it's, yeah, this is running. So it will kill it. Login succeeded. It pushed the changes, but it did not kill it. One equals to one, right? Why it did not perform Docker kill there?
Lokesh, I have a doubt here. So you
Mhm.
have to provide the bill number, the recent bill number here.
It is this is how you actually differentiate the changes. It is not mandatory. It's all depends upon how you actually take care. So Docker PS still running. So let me run this one more time. This should kill it and deploy it. So build success, Docker build, Docker login, Docker push is successful. Why it is not killing it? Oh, it says not found something error. If bracket process check equals, then something is failing at the if condition. FF colon not found. This is right? If then fee, yeah. Let me just verify. Okay.
He closed the braces there, but
Yeah, I
I
closed it here. Fee is also there. Let me add that bin bash over there. If condition is failing here, process check is fine. Dollar process check is equals to 1. Then you do this. Yeah, I think we have here curly braces, right? So this thing must be having some issues. Let's see. I ran 2 times. It again says not found something. Yeah, it looks like it is having some issues executing this command in a shell block.
It is showing error near equal one like that, I think so. Okay. Check something.
This is how we use, right? If statement, no?
Location instead of the braces might be normal one like up docker like that.
Yeah,
But the
this
might be different.
no, this is how we use it, to be honest. So let's try another. Let's write another job to figure out that how this shell is working. Pipeline.
Location if
Mhm.
condition might be double braces instead of the single bracket. If count equal
Yeah,
to
yeah, I will check that. Yeah, so double brace also
create.
works. That should respect the everything. Now I have just used this thing. Count is equal to 1. Apply, save, and then build now. See, it went fine here. It's not found. Okay. Okay, the same error. Now let's use a single brace.
Yeah, that's what.
Unexpected error. Okay, okay. This is considering it as a 1. It says 1 not found. Count not found. Why it is torturing? It should
Location
work. Yeah,
the variable installation might be count.
not like that. It's this is how we use it. I used it. Equal this guy.
Space.
Yeah, I think it's something with the space or something. No. Okay, let's give some spaces here. Not found. Okay, don't give the space here. Dash right. Yeah, it looks like it's the bash way of doing. This is Ubuntu is not respecting this. It's a single. Yeah, it's a single, not the double. So if dollar process check equals to 1, then this. Yeah. Now build now. Let's wait for 10. So building the image, pushing the image. Yeah. So it deleted the image and then it verified it and then it killed it. Okay. And then it deployed the newer one. Now let's go ahead. This is the previous one. Hello guys. Now the new one should says hello Docker. Okay. So this is how the changes works. So now you can redeploy. So since it is a dev environment, so you can kill the existing process and run it. But whereas if it is UAT testing, we don't do that. We just push the image and then we would have a different job that will do the deployments. Like you pull the image and then deploy it. That is a different job we need to create. So now what happens if someone accidentally kills this? Now what happens if you want to scale your application? So you need to have someone manually verifying this, right? So again, it's a pain. So rather than someone manually verifying it, we use the orchestrator here. That is called the Kubernetes. Okay. So let me quick take a washroom break. I'll come. Sorry about that. So this is how we make the changes in the environment. So any doubts? Hello?
No,
Yeah.
we could just at least practice one. So
Yeah.
it will
So
be
now what I am going to do, so in a typical company process, so what we do is, so now we have this repository, right? So uh, I'm going to clone this and push this repo. So I got the clone of this, right? It's a master branch. So let me delete these files. What is the proc file? Okay. So this is your typical source code. Okay. Yeah. So now let me add another repo here. So we are in SUV official, right? Tomcat Maven app. So I have this repository. I'm going to copy this. Let me add the remote, git remote add SUV here. Let me, yeah, let it be the history will be there. Yeah, we don't need the history. This open in nano. Write out is control X. Okay. So this is saved git push SUV minus U, right? I need to use my API token. Let me, I just pushed the changes here. So I'm creating the Jenkins file, whatever data, we have it here. I created the Jenkins file. So now I'm just creating the job. So I'm adding the credentials, Maven, username and password. Password or API token. So where is this is the guy. So API token is added. Jenkins file is this, and apply. So here I am going to do GitHub OKCM trigger polling, so that whenever I make a commit, something happens. So now I am going to take the Jenkins URL. So this is the Jenkins instance, and this is my public URL. I'm going to add it to the webhook configuration. So I go to the webhooks, add webhook. This is the payload URL. Last time we forgot to add this GitHub underscore webhook. So it is running on port 8080. So Jenkins URL port 8080, GitHub underscore webhook. Give a slash. So application JSON. Send me everything. Add webhook. Yeah, it is succeeded. So webhook is working fine. So now what we can do, we can just make the changes here and our deployment will run as it is. So let me make a small change to the README file. Oh, looks like the README file already there. Okay, so this is not the this thing, but let's edit this guy here. It is going to be official. So where is the README file? Edit. SUV official. Yep. I commit the changes. Now the job will run automatically. Yeah, let me try to run it once because it looks like it did not pick up the changes. So it should use the SUV official now. Okay. Port already allocated. Oh, it has a old code. That is the reason. So let's go ahead and fix this. So we know this Jenkins file here, git pull SUV. VM Jenkins file. The issue was with the two braces here. Now let's fix that. Save, git add, git commit, fixing the I pushed the change. Now this should run automatically. What? Didn't I add the GitHub hook trigger SM polling? CV official. Yeah, yeah, it sent the webhook. Why this thing is not running? It succeeded. You see. So why it is not getting triggered? I need to verify. GitHub hook log says perfect. Oh, this is the reason. We're still using this guy here. Git. So let's remove this one. We don't need to do the checkout. This will be checked out automatically. I push the changes. See, started running now. Because of it was still referring to this location calmly, right? That is the reason. But we added the hook to SU official. See, it is now running perfectly fine. See the 13 image. So if we look at our Docker Hub, we would be having 13 different tags. So now the developer knows that but yeah, 13. So now developer knows so which image is having which changes. So in case if he really wanted to go back to previous changes, he don't need to make changes to source code. So for the production, if he really wanted to go back to his previous state, so we know that which image is having the proper change. So Tomcat 3 was having the right change, right? This is hello Docker is coming, but hello Docker is wrong. It should be hello guys. So we know that hello guys source code was created with a tag of 3. So I can simply go ahead and deploy that tag. So let's suppose, and we need to of course do the Jenkins file and all, but in general what we do, this is what we do. So you go here, Docker kill this guy, and then Docker run, say -d -p 8080 colon 8080 with 4. So maybe a third 3 1 4, I think. Yeah, that's it. Now the 4 is up and running. Let's refresh this. It went back to the previous source code. That was very easy way to roll back the changes. So if it is a normal VM, then again you need to identify the jar file that has changes and then redeploy all the process. But if it is a microservice, you don't need to work on majorly. It's very simple. You just provide the image tag that has the previous code, and then your engine will automatically delete the existing Docker image and put the newer image. So your changes will be rolled back with fraction of a seconds. So in fact, if you use the proper orchestrator like Kubernetes, then you don't even see the downtime. You don't even need to download take your application down, because we're killing here, right? So if you are using Kubernetes, you don't need to kill it. So Kubernetes has the smart way of rolling back the changes. So have you ever seen Google or Amazon, Facebook going down? So you use app today, tomorrow you may see a different UI, but the application never went down. So how they were able to promote the newer changes without taking the machine down? It's all because of Kubernetes. So we will explain that more concept in the Kubernetes. So do you guys have any doubts on this so far? Any doubts?
No.
No.
Cool. So then probably we will discuss on the Kubernetes in next class. So in Kubernetes, we will discuss on the like we will use probably EKS. So Amazon Elastic Kubernetes Service. So if you are having the Mac, try to install the Minikube. So Minikube is a single node cluster that you can run off of your Mac, so that you don't need to uh, waste your money on AWS, because EKS is not free. So we may have to spend some money on it if you want to learn it. But if you have a Mac, try to use Minikube. But if you have a Windows also Minikube works, but it's not consistent. So sometimes it works, sometimes it fails. So I cannot guarantee that it's Mac definitely work. Okay, so we will start on the Kubernetes next week then. So just do practice on the Docker, whatever we have discussed. So the Jenkins files also have uploaded here. Okay, so make sure that you definitely follow that. Right, so I have put that Jenkins file here as well and Docker file here as well. So you know right difference why we are using Docker node here, because we just have only single agent that has a Docker. That's why we use same node. If you are using multiple nodes, you may have to add some more steps here. Okay. So let's meet next week, guys, then.
Yeah.
Okay. Yeah. Cheers. Bye bye.
Thank you, Lokesh.